Hello geometry students, my name is Emigh, and this video is our discussion on section 3.1, lines and angles. All right, let's start with some definitions. First, parallel lines. They are coplanar lines that do not intersect. Coplanar means that they're in the same plane, okay? So you have to be able to draw them on the same piece of paper, in the same plane, coplanar. And when we have two parallel lines, we have a symbol that we use for it. We like a lot of shortcut symbols, shorthand in math. So it looks like this, two parallel lines like that. So in the middle, we have a nice diagram. This is right here representing that we are on one plane. These are our two parallel lines, 1 and 2. Now the geometric code that will allow you to say, yes, those two lines are parallel, are these red arrows right here. Sometimes it'll be a single arrow. If single arrow is already used, it'll go up to a double arrow. But regardless, the arrows are what allow you to say, okay, yes, those two lines are parallel. Now the way you would name that is, remember, to name a line, you have to have the symbol over top with two arrows and any 2 points on the line. So we've named our two lines there, and then right in the middle, we put this parallel symbol. That one is red, parallel. I usually like to make it like longer than the letters, just so it doesn't look like an 11 or LL. Skew lines are non-coplanar. That means they're not in the same plane, okay? If you draw one on the ceiling of your house, the other one would be on the wall of your house. So they're on two different planes. They are not parallel, and they do not intersect. Skew lines, you can name, you need the arrows over top, just like naming a line, but there's no real shortcut symbol for skew lines. You would just state that those two lines are skew. So in our figure, we've got CD, so we're talking about this one here, it's in that plane, and EA. So they will never intersect, and they are non-coplanar, making them skew. Let me erase my scratch work. Parallel planes are planes that do not intersect. So think of two walls in your house that if you extended them forever, they would never touch. Okay, that's what parallel planes are, and you can use that same parallel symbol if you want to for shorthand to express that two planes are parallel. Just to review, capital P and capital Q, not points on the plane. They are just like a label, just the name of that plane and the name of that plane. A point on the plane would have to have a dot with it, so maybe something like point R, like that. Two segments are parallel if the lines containing them are also parallel. So basically, you have two parallel lines, you can grab any segment of each of them, and you would also have parallel segments there. So like parallel segments L and M right here. You can use that same shorthand, that parallel symbol, lowercase l and lowercase m. Again, just a little review here. These are not points on the line, they are just labels. They are always lowercase for lines. For it to be a point on a line, you would see a point like that, and then maybe like a capital L, okay? So, all right. Let's practice identifying lines and planes that do not intersect. A, which line or lines are parallel to GH? I like to trace GH with my finger just so it sets into my brain what I'm talking about. And now I address the question, which lines are parallel to that? All right, I see three of them. Well, I see three segments. Okay, this is just a chunk of the lines, but we're gonna address, or we're gonna state them as lines. I see three. Let me show you one of them. One right there. Try to get the other two. If you said this one and this one, then yes, you got all three. Okay, so we only see the segments in the picture, but the line that intercepts those segments is what we were being asked to express. So DC, AB, and EF. All right, which lines, let me erase my scratch work there. Which lines are skew to GH? Okay, so let me draw GH again because it looks like we're focusing on that again. And also pass through point A. So I'm going to highlight A because this is a requirement. It's got to pass through A. All right, think about this one. Which line or lines are skew to GH and pass through A? I see one for sure. Trying to think if there's a, oh, I see a second one. Okay, there are two. If you came up with AD, so this one up here, that'll never intersect with HG. It's the top of the cube or the rectangular prism. And then the other one is AE right here. That will also never intersect GH, passes through A. So those are skew. Tough one. Name any line or lines perpendicular to GH. Okay, here's GH, and I'll give you a hint. It's more than two of them. Lines perpendicular, so form a right angle with GH. Give you another hint. There's a total of 4. If you came up with DH, CG, I think those were the easier ones to spot, at least for me, but then also EH and FG. We've got 4 perpendicular lines to GH there. Last one. Name any plane or planes that are parallel to plane CDHG. Okay, let's highlight that plane. CDHG is this one. It's the side of the rectangular prism. So planes that are parallel to that one. Give it a try. All right, I only came up with one. Hopefully you did 2, and that would be plane ABFE. So the other side of the, if you want to think of like a shoebox or something. And it only requires 3 letters to name a plane. Just a little review here, but make sure they are all capital letters. Make sure they are actual points on the plane, not just a label. And we use the parallel symbol there for shorthand, and that looks good. A transversal is a line that intersects 2 or more coplanar lines at different points. The figure below shows the 8 angles formed by a transversal T and 2 lines L and M. To make that look more like a lowercase cursive L. Okay, so let's start over. A transversal, it's a line, okay? So when you hear the word transversal, think they're talking about a certain line. And it is the line that intersects 2 or more, so it has to pass through 2 or more coplanar lines. That means in the same plane. So all of this is taking place on one piece of paper, one wall, one computer screen. It's 2-dimensional basically. And the figure below shows the 8 angles formed by transversal T, so that one's the transversal, and the 2 lines L and M. So whenever you have 2 lines cut by a transversal, there will be 8 angles that are formed. And we're going to talk about these 8 angles a lot, so get used to them. They are here. These 2 are on the exterior, and these 2 are on the interior of L and M. 5 and 6 are also on the interior. 8 and 7 are on the exterior. And it seems obvious, interior, exterior, but you're going to need to know those terms, okay? It's going to come up a lot, so make sure you understand that interior means between L and M. All right. Interior angles 3, 4, 5, and 6 lie between L and M. Exterior angles 1, 2, 7, and 8 lie outside of L and M. Alternate interior angles. Okay, think of the wording. Alternate interior angles. Alternate interior. So those would be non-adjacent interior angles that lay on opposite sides of the transversal. I don't know if it's harder to read it as the term, alternate interior, or as the definition. Let's look at the picture. That might help us. Alternate interior. So, okay, let's focus on just the word interior. Interior means they have to be on the interior of L and M. So we're narrowed down to these ones. So that's good. We just eliminated 1, 2, 8, and 7. That always helps to eliminate some options. So now we're being asked alternate interior. So that would be 4 and 6 because they're on alternating sides of the transversal, opposite sides, okay? If you need to think about it that way. And then also 3 and 5 are alternate interior angles. They're interior of L and M, and they're on alternating sides of the transversal. All right, you're also going to need to know how to identify same side interior angles. Okay, so let's stick with that plan. That was kind of nice, focusing on the word interior first. So we can eliminate 1, 2, 8, and 7. And it says same side, so that means same side of the transversal. So 4 and 5 are on the same side of the transversal. And interior, so they are alternate interior angles. 3 and 6 are also on the same side, interior. That makes them alternate interior angles. Ooh, I should have said that makes them same side interior angles. So sorry. All right, so alternate interior angles, make sure you know that one. Same side interior angles, it's going to be more. Corresponding angles. See, it's the same picture. It's always these 2 lines cut by a transversal. These 8 angles that we're addressing. Okay, corresponding angles lie on the same side of the transversal and in corresponding positions. All right, here's how I like to explain this one. Picture this is like a traffic stop, okay? And you're in car number 1. There's another car here, and another car here, okay? Here is a different intersection, but who is in the same position as your car? If your car number 1, the car in the same position at the other intersection is 5. That's 1 and 5 are corresponding angles. 2 and 6 are in the same position, so 2 and 6 are corresponding angles. 4 and 8 are in the same position, and 3 and 7 are in the same position. That makes them corresponding angles. So when you hear the word corresponding, you have to know what that means and be able to identify those corresponding angles. Next term, alternate exterior angles. So let's focus on the exterior first for elimination. Exterior, so 4 is out, 3 is out, 5 and 6 are out because those are all interior. So we're down to 1, 2, 8, and 7. And now we focus on this word, alternate. That means on opposite sides of the transversal. So 1 and 7 are alternate exterior angles, and 2 and 8 are alternate exterior angles. Lots of terms coming up. All right, identifying angle pairs. List all angle pairs in the figure. A, alternate interior. B, corresponding. All right, I want you to pause this video now and list all the alternate interior angle pairs and all the corresponding angle pairs. Welcome back. If you came up with 8 and 5, 2 and 3, those 2 pairs for alternate interior angles, you got it right. Nice job. And for part B, if you came up with 7 and 3, 1 and 5, 8 and 4, 2 and 6, you got it right. Nice job. Let me help you with A first if you were struggling with it. Alternate interior. So interior, so I'm going to cross these out, okay? We're only talking the inside of M and N, and then alternate we focus on next. So alternating sides of the transversal, that'd be 8 and 5, 2 and 3. Okay, do you see it now? If you done it before, alternate interior. I'm going to erase that scratch work. Corresponding, here's one of your street lights. Here's another one. Which ones are in the same positions? 7 and 3, 8 and 4, 6 and 2, 1 and 5. That makes them corresponding angle pairs. Okay, that's identifying angle pairs. All right, classifying an angle pair. The photo shows the Hearst building in New York City. The new tower, showing many triangles, was completed in 2006. Well, it's not that new anymore. Right now it's 2020, so it's 14 years old. So this new tower shows many triangles. Fill in the blanks. 1 and 5 are blank angles. 2 and 7 are blank angles. So use the terms you just learned: corresponding, alternate interior, alternate exterior, same side interior, and try to fill in those 2 blanks. Pause the video and try that now. Welcome back. If you came up with alternate exterior for 1 and 5 and same side interior for 2 and 7, you got it right. Let me go to this. I'll redraw it right here because it is kind of dark. Hopefully you're able to see those. 1 and 5 are here and here. Okay, that would make sense then, that they are on the exterior of the 2 lines and they are on alternating sides of the transversal. This is the transversal, so alternating sides of that and on the exterior of these 2. All right, let's try 2 and 7. 2 and 7 are here and here. And that makes sense now. Those are on the same side of the transversal, interior of the other 2 lines. All right, that will conclude our discussion on section 3.1, lines and angles. My name is Jamie Emigh, and I will see you next time for our discussion on section 3.2.